Okay, so now we're going to subtract a couple fractions and then we're going to have to divide it by h. Now, as a side note here, if I said 1 over 9 minus 1 over 5, you guys would say your LCD is 45. Now, if I changed it to 1 over a 5 plus 4 minus a 1 over 5, my LCD would still be the same thing of that first denominator times the second denominator, because there's no common factors. Yes, 5 shows up in each one, but it's not 5 times that whole first denominator. So same idea here on this one. Neither denominator factors, so your LCD is the first denominator times the second one. So our first fraction just needs another x to get our common denominator. So if we multiply the bottom by x, you got to multiply the top by x. For your second fraction here, it needs an x plus h on the bottom. Well, if you multiply the bottom by x plus h, you got to multiply the top by x plus h. So now we can go ahead and write this as one fraction. So we'd have 1 times x. We would have negative 1 times this. Now, remember, we're actually dividing by a fraction here, over 1. But instead of dividing by a fraction, we can multiply by the reciprocal, and the reciprocal of h over 1 is 1 over h. So on the top up here, we could go ahead and distribute this through. We could combine like terms. Notice we have an x minus an x. Now you'll notice, whoa, sorry, we'll try that again. Now you'll notice we have an h times the bottom and an h times the top, leaving us with only a negative 1 on top and an x plus h on the bottom. Next problem, we need to rationalize the denominator. If you only had one root here, you'd multiply the top and the bottom by that same root. But we have two terms here. Terms are things added together. One of them has a root, the other does not have a root. So then you want to multiply the top and the bottom by the conjugate. We're trying to rationalize the denominator, so we do the conjugate of the denominator, which is the same, but you flip the sign in between. So if we do the top by, bottom by that, we're going to do the top by that. So now we're going to FOIL. We're going to multiply them together. Root t times root t on top. That's t. Do our outer terms. Do our inner terms. Do our last terms. On the bottom, we're also going to FOIL our first terms, our outer terms, our inner terms, and our last terms. So now you'll notice on the bottom, your inner and outer terms, these two right here, that we get from our inner and outer terms drop because they're canceling, leaving us only with a t and a minus 16, which we like because we know we don't like to have roots in the bottom. Then on the top, you'll notice you have negative 4 of the root t's and another negative 4 of the root t's. Those are like terms giving us negative 8 of the root t's. So here we're trying to rationalize the numerator. Well, we have, in this case, once again, we have two terms. Once again, terms are things that are added or subtracted. And so then you'd want to do the conjugate of the numerator because we're trying to rationalize the numerator. So it's the same thing, you just switch the sign in between. So that's what we multiply top and bottom by, this special form of 1 in green. So now you take and multiply together this stuff. Now let me ask you a question on the side. If I said root a times root a, you guys know that that's a. So if it's the same thing in your roots and you multiply them together, the roots cancel, leaving you just what's inside because you get the square root of a squared. Now if I said, let's see, square root of a square root of c, you could go ahead and write it as one big root if you wanted, or you could leave it as a root times a root. Would not make a difference. So here, when we do our first terms, this root times itself again. So the root cancels out because it's like the square root of a times the square root of a, which is the square root of a squared, which is just a. Then we do our outer terms here. This root times this root, it's a positive times a positive. Semi-ugly root times another ugly root. So we'll just leave it like that. When we multiply together the inner terms, you notice a negative times a positive. So we get ugly root times a semi-ugly root. And then we'll multiply together our last terms. And negative times a positive is a negative, but it's that same root times its same root. So you'll notice here that we have some things that will help us. This and this match. One's positive, one's negative, so they're going to cancel each other out, leaving us only with this green stuff up here, which we could distribute our 2 into our parentheses. Once again, the highlighted stuff canceled out, and then we could distribute our negative into the parentheses here. So if we do that on top, we get this. The bottom is just h times this whole thing. Well, when you look at the top, you have, in this case, a 2x and a minus 2x. You have a minus 1 and a positive 1, leaving us only with a 2h on top. So the top is 2 times an h. The bottom is an h times everything in parentheses. So you have h times the top, h times the bottom, and special form of 1. You can cross those out. So you're left with only a 2 on top, and then you're left with what's in the parentheses on the bottom. Okay. Now, as we look here, we're going to do a little bit of work on this, just a little bit at a time. Here, you're just multiplying 2 things together. So to help me out here, I'm going to just put that 2x in front. Really not do anything else. When I look at that second part, I have 1, 2, 3, 4 things multiplied together. Well, let's see, a negative times a negative is going to be a positive here. My 2x times that 1/2 is an x. Still times n squared would be an x cubed. Didn't do anything with this parenthesis here, so I'll just bring that down. On the bottom, I have an exponent raised an exponent here, so I got to multiply those exponents, which would be an exponent of 1, so I don't have to put that down. So at this point, you'll notice I have 2 terms here, what's before the plus sign and what's after the plus sign. You'll notice I have a common factor of a 1 minus x squared. But side note here, if I said a squared minus a to the 5th, and you were factoring, would you want to pull out the bigger exponent or the smaller exponent for your greatest common factor? Well, you'd pull out the smaller exponent. Same idea here. When you look at this and look at this, you want to pull out the smaller exponent, which would be the negative 1/2. And then you'd want to look at what's left. Now my red plus sign up here correlates to this red plus sign here. Notice my black in front times what gives me this here? Well, that's just an x cubed. Now here we didn't do anything with that 2x, so that's going to stay there. But the question is, you have to decide, because over here you go x squared times what gives you our x squared, and that was a 1. X squared times what gives you x to the 5th. Well, x squared times x cubed gives you x to the 5th. You have to add your exponent. Same idea here. 1 minus x squared to the negative 1/2 times what will give you 1 minus x squared to the positive 1/2? Well, you'd have to add your exponents. And well, that would be to the first power. Because if this was a positive 1 exponent, when you take this right here times this right here, you'd add your exponents, and negative 1/2 plus your exponent of 1 gives you your positive 1/2. So this negative exponent in front is going to go down to the bottom. What we did have in the bottom stays in the bottom. So now we just have what's in the square brackets in the top. So I'm going to go ahead and look at the square brackets in the top, and I'm going to go ahead and distribute this through. Still have my plus x cubed. Now you'll notice we have some like terms. We have negative 2 of the x cubed plus 1 of the x cubed. We could put those together in the top. On the bottom, we have this to a power times the same thing to a power of 1. Remember, something to a power times something to a power, you got to add your exponents. And so then we get our answer.